Welcome to AP Biology. We're going to go over some more Hardy-Weinberg problems. So this one is a little bit harder than the ones that we did in the first video because they don't give you the percentage of dominant or recessive individuals. They just give you full numbers, like 396 are red-skinned and 557 of these frogs are blue-skinned. So let's start the same way we always do by writing down our knowns. So I've got 396 are red frogs and 557 are blue frogs. Okay. And then it says red is totally recessive. So I'm going to say that means blue is dominant. So big B is going to be blue and little b is going to be red. So calculate the following. First of all, the allele frequencies. So I'm actually going to start the way I usually do. I'm going to calculate Q squared. So Q squared is the folks who are little b, little b. It's the homozygous recessive individuals. Except it doesn't tell me a percentage, right? These are the red ones, which are little b, right? Because we know the blues are either big B or big B, little b. I can't start with these folks because I don't know if they're homozygous dominant or heterozygous. They all look the same to me. But I look at the red ones, I know their genotype. I know they're little b, which I know is Q squared because Q is just one little b, right? But having two of them, that's like a frog. It's got a mom and a dad, right? So it's got two alleles. But I need a number smaller than 1, and 396 is certainly not smaller than 1. So how do I do this? Well, I say a fraction. I want it to be 396 divided by my total. So if I look at my total number here, what I'm going to get, let's see, I think my total, if I add those together, is 953. So this divided by this is 0.42. So now I have Q squared and I have a number for it, so that's good. And then what I usually do from there is take the square root, right? So Q squared is 0.42. If I take the square root of those, I'm going to get Q equals, and the square root of 0.42 is 0.65. Right? You can use a calculator on these. And now that I know Q, well, I can figure out P because I know that P plus Q is 1. So that means P is going to be 0.35, right? So now I have Q and I have P, and it asks me for the allele frequencies, right? So that's what I just found, the allele frequencies. So it's showing me that Q is actually much more common in the population, the little b, right? Which is kind of weird because there are fewer red ones than there are blue ones. But that's okay because there are actually a whole bunch of these recessive alleles in the heterozygous ones, right? So that's why it looks like that. So anyway, that was part A. For part B, it says, what's the expected genotype frequencies? So genotypes would be big A, big A, big A, and little a, little a. Those are my genotype frequencies. And so big A is going to be P squared. And I just found out P was 0.35. So that's 0.35 squared. So 0.35 squared is 0.12, right? So 0.35. Yep. And then big A, little a, that's 2PQ, which is 2 times, let's see, my P is 0.35 times my Q is 0.65. So if I multiply that all together, I get 0.46. And then little a, I already did actually. That was my Q squared, which is 0.42. So that's 0.42. So it actually just wanted these, right? So this, and this, these are my genotype frequencies. And because it's so easy to mess this stuff up, I feel like it's always a good idea to sort of add them up and see if they equal 1 or 100%. And I get 1, so that's good. So that's part B. Okay, so what does part C want? C wants the number of heterozygous individuals that you would predict to be in this population. So you might say, oh, I already figured that out. It's right here, 0.46. True, but they don't want a percentage or a frequency. They want the actual number of heterozygous ones, right? We know that 396 are homozygous recessive, but out of the 557, how many of them are homozygous and how many of them are heterozygous? So I'm going to take my frequency, 0.46, my big A, little a, it's 0.46 or 46%, And I'm going to multiply that by my total, which, if you remember up here, my total was 953. So if I multiply those together, I get 438. And that's the number of heterozygous ones, big A, little a. So that's part C. You didn't see that, I'm sorry. So I did 0.46, which was my frequency here of heterozygous ones, multiplied by my total, right? My total was 953. So I get 438 are heterozygous. So I could actually, it makes sense that 438 is smaller than 557. So these are blue, but they're the heterozygous blue ones, right? And then part D says the expected phenotype frequencies. Okay, so what is a phenotype? So a phenotype is the physical attributes, right? In this case, are they blue or are they red? So I want the phenotype frequencies. So all I need to do is say that this and this are the blue ones, right? So I'm going to add 0.46 and 0.12. So that is 0.58, right? And then my red ones are these, so that's 0.42. And if you add these together, hopefully that equals 100. Yep, looks good. So those are my phenotype frequencies. Okay, so the last part, part E, says the conditions happen to be really good this year, and the next generation has 1,245. So new total. We have more frogs this year. 1, 2, 4, 5 total. So instead of 953 total, now next year I have more. There's 1,200 and something total. Assuming that all of these Hardy-Weinberg conditions are met, there's no migration, there's no selection, there's no sexual selection, they're all just mating and making more babies. How many of these would you expect to be red and how many blue? So how many red, how many blue is what I'm looking for. So I already sort of figured out my phenotype frequencies down here. I said that 0.58 are blue and 0.42 are red. So I'm just going to write that down up here. So 0.58 are blue and 0.42 are red. And so this is a frequency of the total, right? So how many total should I actually have that are blue? Well, it's going to be the frequency times my total. 1, 2, 4, 5. So when I do that, let's see. If I multiply those out, my blue ones are going to be 722 are going to be blue. And 0.42 times my total, it looks like 523 are going to be red frogs. So that's part D. All right, yay?